Hello everyone, welcome to the course. The basic goal of this course is to understand various applications of an electronic device by solving various problems. So, let us start with our basic first electronic device called a diode. What is a diode? A diode is a simple semiconductor device which performs asymmetric conductance. What does that mean? Asymmetric conductance means this device allows passes of current through it only in one direction, and at the same time it opposes the passes of current through it in another direction. This is how the diode works. So let us thoroughly examine the diode characteristics and the symbol of it. This is the positive terminal and this is the negative terminal. This electronic device with various applications is just formed by joining two types of semiconductor materials. They are N-type plus P-type. These two materials combine to form a device called diode. This leads a greatest revolution in electronic era. So, let us discuss the basic conditions what you have to consider while solving a problem, while resolving a network which consists of diode. First condition is, once the network is found, we have to find the state of each diode in the network. Second, once the state is found, replace the diode with its equivalent model. And the remaining parameters are determined. Remaining parameters of network are determined. These are the first two basic steps what we have to consider while solving a problem which consists of this nonlinear device. So, what is meant by state? before studying what is state, we have to study a term called bias. I hope you have heard so many times the word bias, like forward bias, reverse bias, biasing a transistor, biasing techniques. So what does that word bias means? Bias means applying external voltage to any electronic device. So, based on the application of voltages to the diode, our diode falls into two types of states. One is forward biased and second is reverse bias. So this is our time to study the states of a semiconductor diode. State of diode. First one, forward biased. Or on state of diode. As you know, a diode is a semiconductor device which is made of so many semiconductor materials. For example, germanium, gallium arsenide, silicon, and so many devices. So, but in our regular uses, we use silicon diodes due to the drawbacks of the external materials. We don't use germanium or gallium arsenide in our regular uses. Of course, there are so many devices which are used of germanium, which are made of germanium, but in regular uses we use silicon most commonly. So the forward bias or on state of a device means, let us consider a silicon diode. When you find a diode in a network, you have to find the state of the diode based on the pressure applied by the external voltage source in the network. If, for example, I applied a voltage source here with 8 volts, so as you know, the delivery of current from a source is always through positive terminal of that source. So my current matches with my arrow of diode. So now here the diode is forward biased. At the same time, when my diode is oriented in this pattern, my current matches the opposite to the direction of diode. So now my diode is reverse biased. These are the simple steps how to find the state of the diode. So first, the state of the diodes are found, and the next step is just replace the diode with their approximate equivalent models. So after finding the state of the device, what should we replace with the diode? So for example, let us consider silicon diode. In silicon diode, when the device is forward biased, replace the diode with just an voltage source with voltage of 0.7 volts. This is positive, this is negative. If the same silicon diode is reverse biased, replace the diode with an open circuit with voltage VD. VD is the voltage across diode. These are the basic approximate models of a silicon diode. At the same time, VD for germanium diode is 0.3 volts and VD for gallium arsenide is 1.2 volts. VD for silicon, germanium and gallium arsenide are 0.7 volts, germanium 0.3 volts and gallium arsenide 1.2 volts. Based on the given diode in a question, replace the diodes with these sources. So now, the basic concepts of diode have been cleared by us. So now, let us start how we start. We solve a problem when a network is given to us. For the series diode, determine VD, VR and ID. For the series diode, determine VD, VR and ID, and the circuit is the voltage source given is 8 volts and this is VD, this is ID and this is a resistance of 2.2 kilo ohms, which is having a voltage drop VR. So this is the circuit given for us. Solution. As I said earlier, the first step what you have to do is find the state of the device. Here my source is 8 volt source. So it is applying a pressure of current ID in the direction of my diode, my device. So by looking at the circuit, we can clearly tell that the device, the diode is forward biased. Diode is forward biased. Second, after finding the state of the device, just replace the device with approximate model. Here, he had mentioned here it is a silicon diode in the question. So as I had said earlier, for silicon diode, the approximate model when it is in forward biased is replace the diode with a voltage source of 0.7 volts. So replace diode with a voltage source of 0.7 volt. Now the circuit is reduced to this way: 8 volts in series with 0.7 volts in series with resistance. This is 8 volts, this is 0.7 volts, and this is the same resistance who had given with a voltage drop VR and the same current ID. So by looking at the problem, we have already found the first one. VD is 0.7 volts. So now by applying KVL to the loop, we can find the VR, right? So how will you apply KVL? Let us consider in this manner. Let me write 8 volts here, it is not visible. Okay, now when the current is flowing from positive to negative, let us consider that in my sense I have learned like this: when current is flowing from positive to negative, we are reducing our abilities, right? So we give negative symbol before the value. When the current is flowing from negative to positive, we are achieving something, so apply positive before the value. This is just for understanding purpose I created like this. So here my current is flowing like this. So the current is flowing from negative to positive, that means we are achieving. So plus 8 volts, and now the same direction, the current is flowing from positive to negative, that means it is losing something. We are losing. We people don't want to go from positive to negative, right? So minus 0.7 volts. At the same time, the current is coming like this, and it is flowing from positive to negative of VR. That means same, it is losing. So minus VR is equal to 0. That implies VR is equal to 8 minus 0.7 volts. That is 7.3 volts. So we got VR is equal to 7.3 volts. We have determined second parameter, and now, as you know, for the third parameter ID, the current is flowing through the resistor, means by applying Ohm's law, ID is equal to VR by R. That is, what is VR? 7.3 by 2.2 kilo ohms. That is equal to 3.32 milliamps. 3.32 milliamps. So our third parameter is also successfully found. 3.32 milliamps. This is how we can solve a problem when there is a diode in the network. So I hope you understand well. Let us do another problem. You can try along with me by taking a piece of paper. You can try and compare the solutions of me. The basic thing is that people are suffering a lot while attempting solutions in so many competitive exams. This is how we can solve problems very easily. Let us do another problem. For the series configuration, for the series configuration, determine VD, VR and ID. Same question. For the series configuration, determine VD, VR and ID. And the figure is like this. Plus 0.5 volts source with a diode, and he mentioned it is silicon with voltage plus minus VD, and now with a resistance 1.2 kilo ohms with a voltage drop of VR and grounded. This is the circuit given, and he had already mentioned that this is I. So generally any node in the world, any problem, any node in the world will not be given without ground. So a node is like this, the height of a person, for example. How can you measure the height of a person? We can measure the height of a person from ground level, right? So we can measure the voltage, how many volts, from ground level. So the circuit is redrawn like this. Silicon diode with resistance 1.2 kilo ohms with a voltage drop VR, and this is given SI with voltage drop VD. Okay, this is the circuit with 0.5 volts given. See, the circuit can be again redrawn for basic understanding of the network. This is the voltage source. These terminals are same. This ground, this is ground. So we can join two grounds with 0.5 volts and with a diode in series with resistance 1.2 kilo ohms. Understand? This is VD, and here it is given silicon, and the voltage here drop is VR, and the current through it is ID. This is how the circuit is replaced like this. So as we studied before problem, the same concepts VD, VR and ID. By applying KVL, revise the previous problem, we get the answer for this. And the solutions are: ID is 0 amps, okay, let me solve this problem. First of all, what is the basic step what we have to do? First, consider the state. Find the state of the diode. So here actually what happens is, of course, the complication in this problem is, of course, as I said earlier, the current applied, I mean the pressure applied by the source, applied sources to the diode matched the arrow of the diode, but the applied voltage is less than the VD diode. That is, for silicon diode, VD should be greater than or equal to 0.7 until and unless it doesn't become on state. So the applied voltage is 0.5. So it is not in on state. Of course, the current is matching the direction of diode, but the applied voltage source is 0.5. So until then the diode is in off state. So when the diode is in off state, just replace the silicon diode with open circuit and do the same problem. 0.5 plus minus VD, 1.2 kilo ohms with VR. An voltage source, an open circuit, in open circuit current is 0 but voltage will be there. Don't forget to calculate voltage, and don't consider that an open circuit will not contain a voltage. Open circuit will contain a voltage but current is 0. So by applying same, We can find VD. VD is 0.5 and VR is ID is 0. VR is ID into R 0. This is how we can solve various problems of diodes. Thank you for watching this video, and for further classes watch my next video where we can solve so many interesting problems.